right, so now we're working on factoring using a box. So we've done some greatest common factors using the box. We're going to kind of start incorporating this, putting this all together. So today what we're going to do, basically greatest common factor, still working from the box. So you can see here, I have an example on the side where we have the boxes filled in. We've got our x squared, we've got our 5x, our 2x, and our 10. And our goal is to write everything in multiplication as a product of two binomials. So we have a 2 by 2 box. We want to write it as a multiplication of a binomial times another binomial, so a 2 by 2 group. And so what we can see here in this pattern is that in order to make the x squared, we had to have an x times an x, and that's where these numbers are coming from. And then in order to make a 5x, well, it needs an x, which we already have, and it needs a 5. And so that's where this 5 comes from. We're trying to undo the multiplication that we've done with our box. And then we can see here our 2x comes from the x at the top, and it needs a 2 as well. And then just to verify, to make sure that everything works, does 5 times 2 give us our final box of 10? And yes, we can see that that all works. So I'm going to keep this example up on each of the pages as we go through and work this out, but this way you can kind of see what we're getting for each of these problems. So I have, starting with a pretty basic one, we have x squared plus 7x plus 2x plus 14. We've got the box, and we're going to try and work out. So how do I get an x squared? Well, the only way to make an x squared would be an x times an x. And so then we want to work out, well, what makes this 7x over here? Well, since it already has an x in the row, same row as it over here, we know that x times what makes 7, and I would need a positive 7 in order to make that complete. And then down here under the 2x, I need, well, what multiplies to make 2x? Well, I've already got an x from above it in its column, so an x times what makes 2x? Well, I would need a positive 2. And so now we can see if we were to go and write these out as our product of two binomials, I have an x plus 7 is one group, and I have my x plus 2 as my other group, and that would be my final answer. If I was to multiply these out, this is what box would be created. And we can check too, we can see just to make sure that all of our numbers are correct, is 7 times 2 going to give us the 14 in the final box? And yes, it is. So there's one example. I'm going to do a couple more with you guys, and then so I'll have 4 total, just so you can kind of see these as we go through. So our next example, let's try another one. So here again, I'm keeping up this original so that you can kind of see, compare it to what we're doing. But in this next example, I've got x squared minus 7x plus 3x minus 21. So I'm changing the signs a little bit, but otherwise we're keeping the same idea. So I have my x squared. So what makes an x squared? That would be an x times an x. And then how do I get a minus 7x? Well, I'd need my x from my row, which I already have, and I'd need a minus 7. That way x times negative 7 gives me negative 7x. And how do I get my plus 3? Well, I have my x from the column above it, and I would need a plus 3. And then just to verify, to make a negative 21, does negative 7 times positive 3 make negative 21? And yes, it does. So then my factors would be x minus 7 and x plus 3. And there's that one. Okay, so if the box is already filled in, it's pretty easy. We're just pulling out the common terms, what multiplies to make that box complete. So now we have one a little trickier, because now the x squared in the front is not just an x squared, it's a 3x. So we need to figure out what multiplies to make a 3x squared. Well, we know that to get an x squared, we're going to need an x, and undo that. Oops. Let's try that again. We know that to get an x squared, we're going to need an x and an x. But I need to know, where am I going to put the 3? So if we look in the first column, we've got a 3 and a minus 5. Does 3 and 5 have any common factors? No, there's no common factor between 3 and 5. So then what if I look in this row, in the top row? Does 3 and 6 have a common factor? Yeah, 3 goes into 6. So that means that in order to make a 3x squared, I need a 3, and I'm going to put it in the first row because 3 and 6 are in that row and they both have a common factor of 3. 3 goes into both terms. And then I can double check, does 3x times x make 3x squared? Yes, so my first box is complete. So now I need to know, if I want to look on the top column to fill this out, I need to make a 6x here. Now in the example over here, I just used 5 because that's the number that was there. But because our row here, it's got a 6x, but I already have a 3x in the row. So 3x times what makes 6x? And that's what we got to figure out. So 3 times what makes 6? I would need a positive 2. So 3 times 2 gives me the box of, or 3x times 2 gives me the box of 6x. So that's where you got to be, start thinking a little more carefully, cautiously about what numbers you're going to be using to fill those in. And then lastly, so now I have this right here that I got to figure out. What am I going to put underneath the 3x? Well, I've got a box in here that's a negative 5x, and above it is the x. So x times what makes negative 5x? Well, that would have to be a negative 5. And then just to verify, this is how you know you did it right. The last box should be a product of our two numbers. Does negative 5 times 2 make negative 10? Yes. So that means our product, our factors would be x plus 2 times 3x, and I had a minus 5, a negative 5 in order to make that work. And that's how we get our factors, our answer for that problem. Okay, so one more. Let's take a look. Now I made it even a little trickier still, bigger numbers, but they still work the same way. So we have an 8x squared. So we know that we're going to need an x and an x. That's what makes up that x squared in the box. So now the tricky part is I have an 8. So what are the ways we could make 8? Well, we could do 8 times 1, or we could do 4 times 2. So we need to know which of these is going to be our factor. And so when we look kind of vertically in the column, I have 8 and 10. Does 8 go into 10? No, 8 does not match up with 10. But is there a part of 8 that goes into 10? Well, I could either have a 4 or a 2. And when I think about 10 divided by 4 gives me a decimal, so that's not going to work. So 10 divided by 2 does work. So 2 is common to both 8 and 10. And then when I look across the row, my 8 and 12, yes, 2 is common to both, but if I put a 2 here, then that's not going to give me 8. So I need a bigger number. I need it to be able to match or to create an 8x in this box. So if I already have a 2 on top, then I know I'm going to need a 4 here in order to make 8. And if I put a 4 there, what would have to go above? Oops, trying to get my colors the same color. What would have to go above the 12? Well, if I have a 4 already, 4 times what makes 12? Well, has to be 4 times 3. That's how I make that box of 12. And then again here, how do I get my 10? Well, if I already have a 2 above it, 2 times what makes 10? Well, I would need a positive 5. And then again, just to verify, do the numbers that I use, 3 and 5, does that multiply to make 15? And sure enough, it does. So I've completed my box. Everything, all of the boxes multiply to create this multiplication. And so then I can write my factors as 2x plus 3 from the top and 4x plus 5 from the bottom. Okay, and so that's how we get all of these factors to work out. Everything's got to multiply to create what's inside the box. All right, so give those quizzes a try. Make sure you double check. If you need to write it out, I've given you plenty of time to work all of these problems out on paper. All right, good luck.